So what is a relation? A relation is any way to represent a function. So ways that we have represented, or relations we have had, are ordered pairs. T-tables, tables or charts, right, where we have X and Y. Here we are going to discuss mapping diagrams. This one is new. Graphs. We've just got done talking about graphs. And equations. These all represent, these are all relations. These are all representing functions. So let's make a mapping diagram right here. We have input or our X value on the left, output or our Y value on the right. 0 will map to 0, 1 maps to 8, 2 to 16. And these can also be coordinates or ordered pairs where you have 0, 0, 1, 8, 2, 16, and so on and so forth. And can also be a T-table. So here, now, we are going to write the ordered pairs. So I have -2, 3, -1 maps to 2, 0 maps to 1, and 1 maps to 0. More ordered pairs, so I have 0, 1. 1 goes to 2. 2 also goes to 2. And 3 goes to 4. Write the ordered pairs. 1 goes to -1. 1 goes to +1. 4 goes to 2. And 4 is -2. So these are all relations representing a function. A function is where each input has exactly one output. So we are going to make these ordered pairs a mapping diagram. 0, 1, 1, 4, 2, 5, 3, 7. Each input maps to exactly one output. Is this relation a function? Yes, because each input goes to exactly one output. Our inputs never repeat. So I have -2, 0, -1, 0. I don't need to put another 0 because my first point goes to 0. And in fact, all of them will map to 0. And yes, this is still a function because your input values never repeat themselves. Your inputs can go to one output, but multiple inputs cannot split to two different outputs. So let's see what that looks like. I have 0, 1, and 3 in my inputs. I've got -1, 3, and 2 in my outputs. 0 goes to -1. 0 also goes to 3. See how that input split to two different outputs? That's not good. Because of this right here splitting to two different directions, this is not a function. Okay, so let's say 1 maps to 3. 1 also maps to 2, which should tell us this is not a function already. 2 goes to -4, and 3 maps to 2. The only reason this is not a function is because 1 splits off into two different outputs. Does this represent a function? No, because 1 goes to two different outputs. So your input of 1 goes to two different outputs. So because this repeats, it is not a function. Does this represent a function? Yes. Each input has only one output. Now they're all the same, they're all -5, but that's okay. These can repeat, these over here cannot repeat. Does this represent a function? This relation represent a function? Yes. Because each input has one output. Does this relation represent a function? Looking here, I see that yes. And the same reason as above. Because each input has exactly one output. When you're given a graph, there's a test we can see if a function is, or if a relation is a function, and that is called the vertical line test. So if a vertical line touches 2 points on the graph, it is not a function. But if the vertical line only touches 1 point, then it is a function. So let's test that out here. So if I draw vertical lines everywhere on this graph, it only touches in one place. So yes, this is a function. So here, if I draw a vertical line, see how right here it only touches this one, touches 1 point, touches 1 point, touches 1 point, but here it touches 2 points. So this graph right here is not a function. So let's test out this absolute value. See how I'm only touching the graph once? So therefore, this is a function. If I draw a vertical line, right here, it touches twice, so this would be a no. Touch a vertical line, or draw a vertical line, and take it all the way across. It is only touching 1 point on all spots. And here, if I draw a vertical line, I could draw a vertical line right there, and I see that it is not, because it touches 2 spots right there. This one was yes. Also, it touches 2 points right there, so that would not be a function.